Hi, I'm Lauren White. In this lesson, we'll talk together about how to predict if an E2 mechanism will occur based on the base and the leaving group.
First, remember that SN2 reactions and E2 reactions don't truly happen separately. They're always in competition with each other, given that the appropriate substrate and nucleophiles and things like that are there. Various factors, though, will shift so the reaction favors one mechanism over the other. So what we're really looking at here in this lesson is what factors will push the reaction to favor an E2 mechanism. Well, the first factor is substitution. E2 reactions will always be preferred when there is more substitution. On our electrophile, on our base, we want big, bulky things. Why? Well, remember that in SN2 reactions, we wanted minimal steric hindrance on the nucleophile and the electrophilic carbon because our nucleophile has to be able to get in and attack that electrophilic carbon. If there's too much stuff around either of them, that can't happen. However, E2 is kind of what happens if there is too much other stuff blocking the nucleophile from attacking the electrophilic carbon. Instead, what we would see is that our base in this E2 mechanism would steal this peripheral hydrogen from this carbon next to the electrophilic carbon. So the amount of bulk on our substrate or our base doesn't matter at all. In fact, the bigger, the better, so that we don't accidentally go through an SN2 mechanism. The second factor we need here is a strong base. The proton we're going to remove right here is not particularly acidic. It's not attached to anything very electronegative, so it's not feeling very positive, and it would not be as easy to remove as a hydrogen that was bound to something more electronegative, like maybe oxygen would be. So we need a particularly strong base that would be able to pop that hydrogen off despite that it doesn't really want to leave. Another factor you do want to consider is the leaving group. You must have a good leaving group for an E2 reaction to occur. So let's do some examples. And first, notice that in all examples, we have the same leaving group, bromine, which is a good leaving group, so we're all good there. Let's start by looking at our substrate in part A. Our electrophilic carbon right here is attached to only one other carbon, so it's primary, and that's really all we've got. There's not any other groups here. This should already have you thinking that this just doesn't sound like E2. With just the reactant we have here, most nucleophiles should be able to get in there and attack that electrophilic carbon just fine. But what about the base? Well, our base here is pretty small. It's just a fluorine, which is a weak base. This just sounds worse and worse. With an unhindered substrate and a weak base, this is not going to be an E2 reaction. As a side note, though, keep in mind, it would be a great SN2 reaction. All right, let's try B. Let's start with the substrate again. Lots of substitution. Our electrophilic carbon is still primary, but there's lots of other groups around, lots of bulk, lots of potential for steric hindrance. Great, that sounds good. But does anything look suspect here? Well, remember that in E2 reactions, we remove a hydrogen from the carbon adjacent to our electrophilic carbon. But this carbon doesn't have any hydrogens. It has 3 methyl groups. So whether or not we have a strong, bulky base is irrelevant. This cannot go through an E2 mechanism because there is no hydrogen to move, and so we couldn't form a double bond through an E2 mechanism. All right, one more. Part C is very similar to part B, but notice that now in our substrate, this carbon adjacent to the electrophilic carbon has 2 methyl groups rather than 3. So we now know there must be an implied hydrogen there, and a base could steal that hydrogen. Great, and we have about the same amount of bulk in our reactant. We have a primary electrophilic carbon. We have all these other big bulky groups. All right, what about our base then? We have an oxygen with a full negative charge. Remember, that's a really strong base. Oxygen doesn't like to carry a negative charge. It's super reactive, so it's a very strong base. And attached to this oxygen is a carbon with 3 methyl groups. That's big and bulky for sure. Here, since we have a strong, bulky base and a bulky substrate, this would proceed through an E2 reaction. Now, you should feel more comfortable predicting if an E2 mechanism will occur based on factors like the amount of substitution, the base, and the leaving group.